Welcome everyone to our CAWASA Wednesday webinar. And if it's Wednesday, it's CAWASA webinar when we speak from all things from A to Z on water and wastewater. And I'm your host, Ignatius John, the Executive Director at CAWASA. And this afternoon, we are pleased to have with us a team out of Canada, led by one who has had 35 years in a career that was only to be a short stint between jobs, she says, and has worked at various roles in Peel, that time from a plans reviewer for environmental compliance to an inspector administering the wastewater bylaw, to supervising managing the environmental control group, to her current role as Director for Water and Wastewater Operations. And she's supported by some of her team, members of her team this afternoon, and she's none other than Elaine Gilliland. And I can't tell you about what she's going to speak this afternoon. I know that she's going to speak about Peel, what is Peel, and cover some of the biggest challenges, also big events that are happening from 2025, the challenges of protecting the system from a private side system contamination and the main feeder main for rural area failure. So over to you, Elaine, and welcome to you and your team to our webinar.
Awesome. Thanks very much, Ignatius. So yeah, we're going to go through this. Presentation should probably last about 25 minutes to 30 minutes. Then really wanted to leave some time for questions. On the team with us, I've got Mike Winnichak, and Mike is the manager of our linear and groundwater operations. We have Barry Cowan, and Barry's the supervisor of our technical and training team. And then I believe we have Shane Stevens on as well, and Shane is our supervisor of the customer service team. So just some facts about Peel, just in case people don't know where we are. We're in the province of Ontario. If you've ever come to Toronto, you're actually landing in Peel, as Pearson is where the airport is actually in Mississauga. So we started out in 1974, and we had 330,000 people. And right now we're at 1.5 million people and growing. We are the second largest municipality in Ontario, and the second largest water system besides Toronto. We're the fourth largest system in Canada, so it more or less goes Toronto, Montreal, Vancouver, then us. And just to give you a little bit about Peel, so we're a mixed municipality where Brampton and Mississauga are really built out as cities, and then our town of Caledon, it's very rural. Of our population, about 50% of the population are immigrants. And we actually are a very educated community, with less than 10% not having a high school diploma or higher, and 30% have a bachelor's degree. So for our water system, we draw water from most of Mississauga and Brampton and parts of Caledon, mainly up in Bolton, which you'll hear about. That's where we had a problem, from Lake Ontario. So we've got 2 water treatment plants. We have 12 reservoirs, 15 pumping stations, 4 elevated tanks, soon to be 3 because we're actually taking 1 down right now, 2 standpipes, 7 different pressure zones, and 9 subpressure zones. And in total, we're about 4,800 kilometers of water main. About 4,000 of that is just in Mississauga and Brampton, and Caledon is still a lot of wells, and we do have some communal systems there. And every day on average, we're about 600 million liters of water. So on our wastewater system, we're a little bit smaller at 3,900 kilometers. So to give you an idea, just maybe with not knowing the area, our water system, if you put our water system pipes back to back, that would get us from Toronto to Los Angeles. If we put our sewer pipes at the 3,900 kilometers back to back, that essentially gets us from Toronto to Vancouver. So we've got 52,000 manholes, 40 sewage pumping stations. We do take advantage of our elevation. We're about 1,300 square kilometers. for the region of Peel, and our elevation in most places is obviously the lowest at the lake, but we do have some elevation changes through there. So that's why we have the 40 different pumping stations. We have 50 kilometers of force mains. We have an odor control facility because we accept sewage from a municipality outside of Peel. And what happens is with the buildup through those force mains, we do get a lot of odors. And then we have more 4 main sanitary sewer sheds. So just to give you an idea who we are, we have a staff of about 300 people, and 180 of those are frontline operators that do look after our infrastructure. So with our team, the way it's split up is we have our operation and maintenance team, which is all the water wastewater infrastructure, and that's Mike's main team, and that's where our operators sit. We have staff in environmental control that do the administration and enforcement of bylaws, as well as things like spill response. We have a business support team, and they do computer programming for us. They do contract administration. They have a condition assessment team. We have another team that does business strategies and improvements because, much like a lot of operators, you're putting out fires probably 90% of the time, that we really struggle what to work on for improvement strategies, and we do have continual improvement programs. So we have a team of 5 that support all of us. So these are just some photos. So in the actually all of the photos were taken during COVID. So when COVID hit, we had people separating, which is the upper picture in the middle. We had people sampling and doing the bylaw enforcement and administration, all wearing masks. We have a sewer repair team on the bottom left. And the bottom 2 pictures, the one in the center on the bottom is our wastewater treatment plant. It's a traditional plant, conventional plant. And then we have our APK water facility on the lower right-hand corner. That facility is the largest membrane filtration water plant in the world. But up in the upper right, one of the things that our teams do, we respond to spills. And during COVID, nobody expected the pandemic and the deaths and everything else. And there was a spill of some red ink, and it turned a creek red for kilometers. It made CNN, it made some of the other large news outlet just because the nature of it. And people made a number of biblical references at that point. About how rivers turned red ancient times ago. So we just put that one in there because it's something we do deal with on a regular basis. So as I say, we also have what we call our North Peel water and wastewater system. We have 6 smaller systems consisting of a number of community wells where Peel runs them and does the distribution of the water versus people having wells, because what we're finding is homes are getting built a lot closer together. We can't get lake-based water up there because it costs so much. So people or Peel has installed the smaller systems because we have a lot of people have moved out of the city and they don't understand well water, they don't understand septic tanks and everything it takes. And we have one communal wastewater treatment facility. This was installed because somebody decided, oh, this is a great little area, we'll build 100 homes, and didn't think about supplying wastewater to them. So at the last minute, they had to install a really small wastewater treatment facility, and it discharges directly to a creek versus back through a full traditional plant and out to the lake. So some of our challenges, and this is where I'm going to ask Mike to jump into, obviously weather is one of our biggest challenges because living in Canada the other day, it was 8 Celsius at, 6 o'clock in the morning. By 1 o'clock in the afternoon, it was 32 Celsius. So we go through extreme weather extremes, different weather events, ground composition, customer service demands. We have a council that's very, very active and puts a lot of complaints through our office to move them up, as well as being regulated. So Mike, anything else you could maybe add there or talk about some of these?
Sure, I could. One of the biggest concerns, again, I'm not sure how familiar everybody is with Canada, and we're not in the coldest parts of Canada, but we do get well below freezing in the wintertime. So what does that mean? So I understand that most of the tropical warmer climates in the world, they can have their water mains a lot closer to the surface. Unfortunately, if we had our water mains that close to the surface, they would freeze solid, or certainly have the potential to. So depending on where you are in Canada, we have regulations on how deep we have to put our water mains. In this area, you're looking at, let's call it approximately 2 meters below ground at a minimum. That means that in the wintertime, the ground has the potential to freeze. And if our water main happens to be in a shallow depth, it potentially could also freeze. Movement would help. Water movement would certainly help, but you never want to take that chance. There are areas in Canada where water mains are have to be well over 10 to 15 feet deep because that's how deep the frost line is. So that's a challenge. And why is that a challenge? Well, number one, if you have to dig down that deep, some of the safety concerns that you have to consider comes into play. For example, if you dig a water main and it's only up to your kneecaps, for example, the odds of something happening, or even to say mid-thigh, a collapse of the walls of your trench that you're digging is probably, not to take it too lightly, isn't going to be a matter of life and death. But when you're 12, 15 or feet or deeper and a wall caves in, it could be very, very, very problematic. And as fast as you think you are, I assure you that wall coming down will not give you a heck of a lot of time to get out of the way. That's why we use, shoring to basically hold back the walls and protect the workers that are down that deep. Ground composition. Again, we have a little bit of everything here, from sand to clay to rocky to shale, all making it a little bit more difficult to dig. And I'm not sure what things, what your customers are like in the areas that you guys are working in, but around here, it seems like there's less and less and less patience for delays. People want things done yesterday, and if they don't get satisfaction, they're not too shy about approaching counselors and escalating and trying to get you to move along. And of course, the last thing is regulations. We are pretty tightly regulated. And it's a good thing. Everybody wants to make sure their water is clean and safe to drink at all times. So we do a lot of sampling, sending the samples to labs. So it does, makes your jobs a little bit more complicated.
Yeah. And one thing that we'll talk about, where Mike was saying the depth of our water mains, just because we're in such a congested area, our water mains and our sewer mains are getting deeper and deeper, and we have a project that is going to divert some flow from one of our treatment plants to the other, and it's sitting at, I believe right now it's 100 meters deep. So if you try to get specialized pumps and equipment and people trained that are comfortable enough to work there, that is one thing. And once you start on a water main, and we can't really talk a lot about it, but we'll give you just a bit of a highlight. We had some contractors in working on finishing off a building and doing a couple of deficiency repairs on a water main in our city center in Mississauga. High pressure in that area. The water main was around 30 meters deep. They did not depressurize the line. One of the bolts popped off, killed one of the gentlemen in there. We ended up having to have fire come in and do a recovery service because the gentleman passed away, and they couldn't, and workers couldn't get to him because the amount of water that was in there. And there's a lawsuit that has happened, and people were charged with involuntary manslaughter and one other charge, and the trial is coming up very shortly. So we put safety to the forefront of what we do with a lot of things, and it just makes the job a little bit longer, but it's things that we do have to consider.
Yeah, and just to add on to that very, very quickly, you know, traditionally we would probably have, you know, water mains say 15 to 20 feet deep at the deepest. People were okay with that. Now, when they're 100 feet, sorry, 30 meters, you know, 40, 50 meters deep, it takes a special person to be comfortable to go down there and look up and see nothing but darkness except for a little tiny speck of light way above it. So there's going to be some challenges moving forward in trying to adjust and adapt to everything just getting that much more deep in our system.
So just wanted to talk about a couple of recent challenges, and I'll start with this one because I think I was a little bit more involved because once again, it became very political. So on a Saturday night, we had an arena, ice hockey arena. People were at the facility reporting that the water was cloudy, it didn't taste proper. So we sent staff out and they did some sampling at our fire hydrants just outside the facility. Everything was fine. And in our system, we can't cross into private property. So this went on Saturday, checked it again on Sunday, didn't do anything to the system. On Monday morning, we ended up having to model it, ended up isolating the facility. So, and we shut their water down. We kept testing our water and we had staff go out testing throughout the facility. And they were getting hits of glycol. They were getting a couple of other chemicals, and it was coming through both cold and hot water at the concession stand, in the showers, hadn't reached everywhere in the facility. So we had asked, this was a city-run facility, so we worked with them, and what ended up happening is we're going through everything in their internal investigation. They brought in plumbers, everything else. And what they had installed was, as a feel-good climate change project, they installed a heat exchanger between their hot water tank and the main water supply for the facility that supplied bathrooms and concessions and the filling line for the ice. And one small broken pipe filled their whole system with glycol, so antifreeze. And they did not find that until about day 3 or 4. It took them 4 days of flushing because of the isolation, we were still able to get them water, continue to flush the system. And it was the busiest time of the year where it was March break for the kids. So when a lot of Canadians inundate everybody down in the islands to get some sun in the middle of winter, there are some crazies who stay at home and want to ice skate and do things like that and continue to enjoy the cold. And this, between registration fees, analysis, like the bill for the analysis alone was over $50,000. As we were going through everything, found out that they didn't have a backflow preventer, didn't have system isolation. So this is something where, even though for us it came from an arena, this is something you could see potentially at a resort, at different attractions, where problems on private property, you know, the first thing is to point the finger at the municipality, where it's you having the problem, everything else, when in reality it was there. So this was something, you know, if people are interested, we could definitely go into more details. But Mike, anything else to add with that one?
Actually, I'm going to ask Barry to jump in.
Okay.
Time, yep, and see if you can kind of fill in the story a little bit.
Yeah.
Absolutely, yeah. So one of the programs that we're really big on, it's legislated, is backflow prevention, and that was one of the failings in the modifications that the arena had made to their system, was I don't believe there was any backflow prevention that was installed, Elaine, let alone inadequate, right? So had that have happened, had the backflow preventers have been installed correctly and tested and certified, the event, it would have been a non-event, right? So again, so that's another one of our main ways of safeguarding our system. Even if we have a water truck that wants to take water out of a fire hydrant, there has to be a certified reduced pressure zone principle backflow preventer attached to the hydrant that we certify, and then allow them to fill, and we charge them for whatever water they're using. So.
Yeah, and I just changed the screen. So Barry, can you just explain? This is a screenshot out of something called iPal, which is our Peel Asset Locator. And I only put water lines on the screen, but these are all maps in GIS of all of our water lines and wastewater lines. So Barry, back over to you.
Okay, thank you. So you can see there's the 300 PVC water main. That was the supply. That's our water main there. It's just a local water main, feeds all kinds of different businesses. It's a part of our distribution system. Where you see the 150 PVC, that's the actual service line going into the facility. So we isolated it at property line. That's our demarcation point, is property line. We have a valve there. It would be a 150 mil valve, 6-inch valve, and just to ensure the integrity of our system.
Thank you.
The one thing that was of concern, if you look to the left of that big gray building right there that Elaine is pointing out, is a residential neighborhood. So what the fear was it possible that the glycol exited the building and potentially made it into the supply of water that is feeding those homes? Highly unlikely, but a possibility. So that was one concern that we did have. We ended up shutting the valve to the left of the building, preventing it from going to the west. You wouldn't know that necessarily from the drawing, but going to the west and entering the homes until we were absolutely sure that they had everything repaired. And there was no way they had the backflow installed, so there's no way that glycol could have made it out of that building.
Yeah, thanks, Mike. Thanks, Barry. And the one thing is with this one, it wasn't just water, wastewater. We had our health department out because it was an indoor water quality issue, because there were so many members of the public through there. So they were overseeing a lot of the water flushing. They were the ones making the calls saying, yes, they actually put a do not use order on the facility for any of the water. So until we got all the chemical results back and it was clean for a minimum of 48 hours, that's when health department came in and actually lifted that. And as Mike said, with having the residential area just over here, one of the challenges was as well, this started on the Saturday night and we actually didn't isolate the building until the Monday or Tuesday morning. So it was a little bit of a lag on our side, but we eventually got there. So yeah, so these were the actions. So we isolated the facility, we involved health department operations, flushing, and then the installation of a backflow device. So this is one that has just happened. And Shane, are you on the line now?
I am here. Can you hear me?
Okay, yes, we can. Yeah. So
Good.
between Shane and Barry, so we have something in Canada under legislation where we have to have an overall responsible operator for our system. And for that weekend, it was actually Barry. And then Shane, as our customer service supervisor, went up to help out the team on this because the road that you see the gray car on is the divider line essentially between Brampton and Caledon. So our Caledon team is a lot smaller and not necessarily aware of a lot of this. So I will so what had happened, and I'll start it, then I'll turn it over to Barry. I got a call from actually one of our team saying, hey, we've got a water main break. It was reported to us by City TV, which is one of the news outlets. So we were like, okay, we don't quite know how that happened. And this was actually a video, and I can't remember if this came from Shane or one of the other team members at the beginning. So I don't know who wants to start and take it over.
Yeah, I was there.
Okay.
From the beginning, so I'll take this on. Yeah.
And I'll change slides, Shane, because you've seen them. So I'll try to keep up with what you're speaking about.
Yeah, this one came in. I can't even remember what day of the week it was, but
It was a Thursday.
Thursday, 4 o'clock in the afternoon. I got a call to go up and help them out because this was on the borderline for Brampton and Caledon. And if you see the next slide there, it was the 750 millimeter CPP water main. Right there is where it broke. And if you see, it's all farmland around there. But just northeast of that location is a small community of 27,000 people with lots of industrial. And that is their main feeder pipe going up there to feed their wells and their towers. Yeah. Right beside it, we had the 300 PVC, which also heads that direction, but it wasn't enough water to support that town's needs or that little village's needs. So yeah, we got there the Thursday night. We started planning right away. We had meetings, I think every hour and a half.
So sorry, Shane, and I'm not sure how many of you have maps like this, but maybe just walk through some of what the indicators are, and then as we go in, just to help out a little bit. Sorry, thank you.
Sorry, this is actually two different zones. We have our areas broken up into zones, as Elaine mentioned earlier. So this area is a borderline for a lot of our zones. All the water mains to the south of where we are, all head into Brampton, and then everything north and then east head up and towards the Bolton area. And that this map shows us where all our valves are, where all our interconnects are, where all our fire hydrants are, and it gives us a lot of very useful information, which we relied on a lot that night. With that and drawings. The old drawings helped us out a lot too. Yeah, operations staff were on site when I got there. We weren't sure what to do yet. We knew it was a big water main. We kind of had an idea what the problem was. So Elaine started having meetings with all the engineering, modeling department, SCADA department, compliance, and communications, because we had a major road closed down at the time and it was heavy truck traffic road. So we had to communicate a lot just to help everybody get around the situation. So the planning part, this was all the planning part, and that was the biggest deal of it. We had project managers online with us looking at drawings from like years ago, and there was just information that we got from the drawings and the as-builts. And we had we have a flow modeling department. They were on the meetings with us, and we're doing different scenarios. What if we close this valve, close this valve? Originally, we thought we had 24 hours before the little village of Bolton would be out of water. But as we started these meetings, I think it got knocked down to 14 hours. Mm-hmm. So we were kind of rushing, but we wanted to be prepared so we could just get it going. So we had our contractor on site. He had a brand new piece of concrete pipe. I think he got there at like 3 o'clock in the morning, on site, ready to go. We have our welder that we used, and he had an oversized blind flange on site on the trailer because we didn't know what to expect, because we couldn't start digging this up until the water was shut off. Because of if we took the asphalt off, it's so thick, the water just would have been shooting everywhere. So we had to be prepared. As soon as the water was off, we could just start going. And then I think it was 11 o'clock in the morning, we shut the water off, and it took us a few hours to drain.
Yeah, that day we drained in the pipe, to give an example, 625,000 liters of water.
Yeah, it was 1.2 kilometers of 750 millimeter pipe.
Yeah.
And we were at the bottom of the hill. Everything was flowing down to us. So it did help us out in the long run there. So so we had everything on site. We had PVC pipe in case we had to do a temporary bypass. Everything was on site. And then it was like, okay, let's shut the water off now. And we had a really good shutdown. And we dug and dug and dug and dug. It was a deep hole. It was a big hole. And then we found an old flange that was leaking on the one side. If you see the picture to the left, that's where you see the ribs on the concrete pipe there. That's where the water was leaking at the side of the flange. So we got everything exposed and drained and drained. Once we got it drained, the welder went down. They pulled the old flange off. He was able to take measurements, and the flange he had on site, the flange that was leaking was a 24-inch wide flange. And the one he had brought with him was 36-inch. So we knew it was going to cover up that area that got affected.
Yeah.
Yeah.
And so this was just modeling that was done just to give you an idea. So as Shane said, it was originally about 19 hours is what we projected. And it came down to 14 based on the water usage. And at hour 14, when we got to a point of about 20%, everybody with the red dot, these were all the areas that would be out of water. And so the town's about 36,000 people. So at night, on the Thursday night when this started happening, we were working with our communications team for the road closure, but we also put in a mandatory water restriction. So nobody could do outdoor watering, tried to limit indoor water use. So we had our environmental control team go to all the high water users and say, no indoor water use today, none of this, none of that. And it cut our percent water usage from about 10% down to about 3% per hour. So that's what gave us a little bit of extra time. So as Shane said, the break started over around here, and as it progressed, this was around 11 o'clock in the morning, and you can just see the decrease throughout the day of the water level in the tank. So these are measurements of meters. So basically at 3 meters, we call it a 0, and we were at a 4-meter level. And then that's when the repair was done. So we were getting to a point where we would have had everybody out of water, and then once the repair was done, started filling the tanks again. So this is just a timeline of when everything happened. As Shane said, informed of the water leak, reviewing basically Thursday and Friday. On the Thursday, I think our last meeting was around 11, and on the Friday, our first meeting was around 5 o'clock in the morning. But it really took a village of getting the shop drawings, the shutdown plan, walking through all the scenarios, and then 11 a.m. was there, work throughout the day, and then at 3:30 in the morning is when we were able to restart filling again. So with all of that, those are kind of our larger scenarios. But the one thing that we have a challenge with in the province of Ontario, we have about 1,200 to 1,500 licensed operators. So to operate in Ontario, you have to possess certificates or licenses from the Ministry of the Environment, Conservation and Parks. And we start off people with an operator in training, get their experience, and then they work up in the licensing. So Barry and his team, as I say, they're our training and technical support team. So maybe Barry, I know our next one, it talks about our website, but if you want to talk about some of the recruitment and that, then I can open up the website as well. And hopefully.
Elaine, just one observation. The
Yeah.
certification that we go through in Canada is exactly the same one that CAWASA operates in the Caribbean.
Perfect. Then. So everybody's aware with the hours. So that's great knowledge to know. Thanks, Valerie.
Excellent. Yeah. So we're actually on a recruitment drive right now. We've just hired 12 people that we're going to be starting out in the middle of October. Super excited about that. Some of them have years of experience, and others are brand new coming into the industry. Our interview questions themselves are really more of a technical nature. What we found before was that we were really, because it's an outdoor 4-season job. You're going to be working, with a Humidex reading of 44 degrees Celsius, or you might be working in minus 35 degrees Celsius. We were finding before we weren't attracting necessarily outside workers. We were attracting more people that thought that they were getting into a laboratory environment. So we've really changed our recruiting questions and even targeting who we're looking at getting. It's been really successful so far. We've got we've hired over the last 3 years probably about, I don't know, 45, 50 new people. Very successfully. We break them up into groups. We have mentorship programs. It's working out really well, and they're becoming really well-rounded operators. We put them, we have all kinds of different disciplines. We do everything from, you know, large construction jobs, doing repairs on again, like on that 750 water main, that type of thing, doing hydrant inspections, and everything really that falls in between, valve inspections. We have a lot of capital works that are going on constantly as our system grows and as it ages. As it grows, we need to install new pipes to new areas that, you know, traditionally were farms, really, and also because, I mean, Peel was formed in 74, but certainly Brampton, Mississauga, and Caledon have been around for a lot longer than that. So we still have, you know, pipes in the ground that are 50, 60, 70 years old that are, you know, reaching their limit. So Capital Works is very aggressive. We support everything that they do, as far as turning the water off, turning it on, sampling, commissioning, all that good stuff. So it's it is an exciting job for sure, and it's an exciting place to be right now.
If I can jump in very quickly, I'm sure that most people here know that the book learning, the education piece is wonderful. That gives you a nice base to learn from. But at the end of the day, it really comes down to touching things and working on things that builds up everybody's skill levels and experience. And that's what it comes down to. So we appreciate and try to take advantage of the people that have been in the industry and pull as much information from their heads as we can and try to educate the people that are newer. Yeah, for the people that have been in the industry for a long time, you are valued. I'm sure down in your system as we value the older folks up in ours.
Yeah, thanks, Mike. Yeah, and the one thing I just had read this on, I think it was LinkedIn, being a water operator is the second most resilient job to a future of AI. So that's a good thing there. Now, as Barry talked about, one of the things that we did look at was how do we recruit? So we have an education outreach team. We participate in something called Level Up. We did it last year. We're doing it this year. It's where they bring high school students to, and what we can do is really promote the water industry and the jobs and that type of thing. And what we did, and I hope if I do a control click and this shows up, you guys can see our website, because it's not really liking it. Oh, there that might work. Can you see the new screen?
Not yet.
Oh,
I saw the little circle going round and round.
thinking.
Hasn't come up yet.
So now it says what's showing on my screen, and I think it's there is a career spotlight in water and wastewater. And if it doesn't work, we'll get the links out to Valerie and Ignatius for sharing. But
You
this
can
really
put it in the chat. Link in
okay.
the chat, so yeah.
I will do that. Yeah. And what this really does, it talks about being a career, how we have a healthy workplace, our professional development, work-life balance. Our staff they work 4 days a week. So you get every Monday or Friday off. So that's a real big attraction as well. And the one thing that we found that was great is we actually have a people in Peel segment where it's one of our newer female staff really talking about, 6 months ago, she knew nothing about water. Now it's great. There's stuff about fire hydrants, kind of the why we exist. Talks about different operator responsibilities. And the one thing that has been really great is we've actually posted what our salaries are. So that has been something because people, whether they don't really consider that, but when we start talking, you know, a starting operator in training, you're making around $34 an hour to start. So it becomes really a viable career for a lot of people. So it has been really, really good there. So that's kind of the end of our presentation. So I'm going to stop the sharing. I'll drop the link in the chat for that so everybody can check out our website. But yeah, if people have any questions or anything, definitely Shane, Barry, and Mike are all more talented than I am. So ask away.
Thank you very much, Elaine, for sharing with us your own experiences, challenges, and how you sought to overcome some of your challenges. And I'm pretty much interested in your operator in training program. I don't know if you did give some more pointers of how you made it more attractive by even publishing what salaries they attract. And so that's pretty interesting. So I'll open the floor to the participants. I think we have quite a few operators present, so they may wish to pose some questions. Thank you.
Yeah, and we can actually do, so I dropped in the chat the link to the website so you can see it. You know, something else that we can come back another time is really talking about, we have two programs, which is appeal hands-on training, and then we have blocks training. And don't ask me what block stands for, but it's like building, learning, something knowledge and whatever within the operator knowledge. Then we now have a sub 4-person training program and soon to be a 4-person training. So as people work through the career, making sure we're there to support them.
I'll make sure I book you.
Okay.
We can go and talk about that later
Yeah.
on in the year.
One thing I found with our blocks training, which we just started this a couple years ago, and talking to the newer operators coming in, they are enjoying it because they're getting a chance. They're not being stuck on one job for months. They're every couple, I think it's every 2 months or something, they're put onto like a construction, and then 2 months later they're put into a maintenance, and then 2 months later they're put into a customer service. So they get to learn every role that we do and not just stuck checking fire hydrants for their whole career.
Not necessarily become experts in that time frame, but to give them a taste for it, and hopefully that gives them a better idea of, you know what, I'm really interested in this, and then they can kind of move towards that.
Yes, Natasha, please, you have a question? No? Okay, I thought I saw a question. No.
I was just wondering, Elaine, you mentioned that you've got 1.5 million customers.
Mm-hmm.
I don't know how many connections you have, and you have a staff of 300
Yes.
to service 1.5 million people. Could you break down for us how that 300 people are? Because that's, you know, I think people might be interested in sort of your ratios there between customers and staff.
100%. Yeah. So of the 1.5 million people, we actually have around 340,000 service connections. We have, of the 300, approximately 20 of those positions are intern type positions, or students that we bring in to learn the business, but more on the office side, not necessarily the front line. We have 180 operators. We have around 60 in construction. We have around, I think it's 60 in our customer service team. We have 18 in our wastewater plant operations that look after our sewage pumping stations. We then have about 24 in preventative maintenance. And then our small distribution team in Caledon is about 9 operators. And then our treatment team in Caledon is about another 10 or so. For a ratio, we have about 2.2 operators for every 100 kilometers. of our system. We're the lowest in Canada on that rate, where the average is around 4.
Thank you.
Okay.
Okay, thanks. We have Kevin Carter on with a question. Proceed, Kevin.
Yeah, hi, can you hear me?
Yep.
Yes, Kevin.
Great. Hey, great presentation. What an incredible system. Could you talk about your standard operating procedures for maintenance for such a large facility, particularly the equipment that you use, generators, relief valves, those types of things, and how you seek to keep those operated?
Kevin, we lost a little bit of you
Yeah.
in the middle there with your question.
Oh, I'm sorry.
No.
Could you talk about your maintenance your maintenance program, particularly like with generators and things that you don't use all the time?
Yeah, so we've got a couple of different approaches with our generators. So with the ones that are at our wells and our sewage pumping stations, which are a little bit smaller, on our water side, it's our staff who do them. They do a check once a month. They run them for about 30 minutes just for load, making sure the switches go back and forth. On our wastewater side, we have a contractor come in and do it, because if we can't get water somewhere, we can push water around. When the sewage isn't flowing downhill, people get a little bit upset about that. So we have a contractor come in and do that. They check the loads, connections, everything else. We have a really difficult time sometimes with the switching back and some of the VFDs, only because the humidity within the sewage pumping station kills some of the connections and the wiring. At our water and wastewater plants, for those, we have contractors come in and test those. We run those a lot more on a monthly basis. We'll run them 1 to 2 days a month. 2 reasons for that. We have what we'll call is energy saver days, where if we can save energy and reduce our energy consumption via electricity or other forms, we actually get a cheaper energy rate. So we try to align our generator test dates with those, so that we're running the plant on generators. We know they work, everything else. And it last year, just by doing that, it saved us about $6 million in energy costs. Because part of the challenge is where if you only run them 10 or 15 minutes a month, yes, they work, but we don't know all of the load switching. So we run it through a whole program, making sure, we've got VFDs working, the loads, that we can see it on our SCADA screens, and that everything runs smoothly. We can definitely get you some more information on those, because we've got a lot of different SOPs. And the other thing that we're doing right now is we've actually got a consultant in. That's where I was before this meeting. They're actually reviewing all of our preventative maintenance program, what our valve program should look like, what our manhole inspections, flushing, everything else, because it's something that a lot of times you'll have somebody did it this way, and then when they bring the next person in, they did it this way, and then they've got shortcuts and they're not following the SOP, then you're not getting everything. So we're trying to put together a new picture so that we don't get those bad habits kind of pushed down, if that answers your question.
If I can throw in very, very quickly,
Yeah.
too. We do have people that come in and check for vibrations in the pumps and motors.
Yeah.
That are unusual. They also check for heat, like thermo stuff. And then lastly, efficiency testing. That's for the pumps in the pumping station. But as Elaine alluded to too, from a preventive maintenance perspective, we inspect our hydrants, approximately 30,000 of them each and every year, because that is a bylaw to make sure they're operational, that they are winterized, so that they don't freeze solid when you go to need them. They're draining correctly. We inspect all our large and small valves. Large valves on a yearly basis, small valves on a rotation over a 3-year cycle. We inspect all our manholes to see if the stairs are okay, any infiltration, cracks, anything at the bottom of them that could be impacting flow if it comes for sewers, things along those lines. Hopefully, I think we've touched a little bit on everything there for you, Kevin.
Perfect.
Yeah.
Perfect. Thank you very much.
Right.
No
We
worries.
have 2 questions in the chat. I'll take them first, and then we have Stefan Tyndall after. So the first one is, can we get a little more information on BFP backflow prevention valve, for example, regulatory requirements, and perhaps a typical valve example?
For sure.
And two, the other question is, what are the major sources of water for domestic purposes in Peel? Is the effluent from the wastewater treatment plants recycled into the system as well as other purposes?
Okay. We'll do the backflow one first, and this might be something, we have a great presentation on backflow. So in Peel, we require a multi-barrier approach, and the type of backflow you need depends on the rating of your facility. So high risk requires RPs versus being just a double check. We don't allow single check for backflow because that's no longer considered backflow or sufficient for backflow protection. Each facility has to do a survey if they're anywhere within an industrial or a residential that is more than 3 stories. Does require that they have to do a survey to see where the backflow risk potentially are, submit a plan for installing backflow, and then they actually have to put a plan in place to install the backflows, and then annual checking everything else. So I know that was kind of quick, but we can get you some links into that program as well.
I think that would be a good presentation to make, Elaine, because we're just working with one municipality in the Caribbean, and we asked them about their backflow, and they said, "What is a backflow? What is cross connection control?" They
Yeah.
were not even aware of what that was.
So
And
yeah,
they had a pipe coming up, and what they had done for overflow, they had drilled a hole into the pipe, so it just overflowed. and they said, "Well, what about contamination?" Well, what are you talking about? So
yeah,
this would be a good presentation, I think, Ignatius, to have.
100%, and especially the intricacies around irrigation systems and the need there because people don't see them, where you've got large sinks with those fun
Aspirators.
yeah, that pull down. Once it goes below the level of your sink or sitting in a sink, that is the biggest source of cross contamination you can have. And people just stare and just the blank look, and then all of a sudden it's like, oh my gosh. So yeah, that's a great one. I love backflow. I was the one who helped write some of the bylaw. I got the training. A lot of us all have the backflow training because we did it as a group. But yeah, it's between backflow and you start me on about Legionella. Yeah, I could talk for hours. So yeah, we can definitely do something for that.
Elaine, I think we should go down there and help them out for like January, February.
100%.
Yeah.
100%. I'm even remember, yeah, I'm there with the Shane. I've got my passport. It's actually in my purse. I can come tonight.
I'm already packed.
Okay, there you go. So the question around the major sources of water for domestic purposes. So most of the source of our water comes from Lake Ontario. In through Peel, the water usage is about 55% residential and 45% industrial. We have major thoroughfares, so we actually supply a lot of Eastern Canada with food products as well as the upper part of New York State and some into Ohio. We have Coke, we have Pepsi, we have a potato chip company that every single week sends 17 tractor trailer loads of potato chips to Florida for use in the commissaries in the Florida jails. They do all the no-name and store brand potato chips. We have a lot of meat producers, and that's just because highway access. We have the cheapest water in the Greater Toronto area by about 35%. we allow, because of the size of our plants, we do allow them to have surcharge where they pay us to treat their wastewater versus them treating it on site. So we don't have any recycled water right now. What we are using our effluent from the wastewater treatment plant for is actually feeding into a district energy system because of the heat value of it. So we have a neighborhood being built right beside our wastewater treatment plant, and we're feeding our effluent over there so that they don't have to have traditional heating and cooling systems. They can do it all by a district energy system.
If I can add, we're actually very fortunate. Lake Ontario is a great source of water. It doesn't actually require a lot of treatment in order for it to get up to, drinking water quality. And it's quite large kind of thing. So it's being in a fortunate spot, having a great source of water, and then being able to distribute it all the way up to the north, which is the south to the north region of Peel is approximately 35 kilometers.
It's a lot more than that.
That's
Going from Wolfdale up to Caledon, you're almost 70 kilometers.
okay.
Because from Wolfdale because from Wolfdale to 10 Peel, that's 22 kilometers one way.
Okay.
So we're quite a bit bigger now. Yeah.
Yeah. Any other questions? I see some.
Stefan.
Yeah, we have a question from Stefan Tyndall. Please unmute, Stefan. Go ahead.
Can you hear me?
Yep.
Yeah. Clear.
All right, great. So I was just commenting on the response to the leaking pipe, and I noticed you talked about, the valve turns that it would take in order to do a bypass to see if you can supply that community where the burst pipe occurred. But I was just wondering, how hard was it for you, with this network of your size, to establish a hydraulic model? And do you have a digital twin for that hydraulic model?
Okay, so yes, so we have a team of hydraulic modelers, and Shane can add a little bit more here. So we had 2 of our 3 hydraulic modelers working beside us. They will model different scenarios. Do we have a full digital twin right now? No, it's something we're working on. But yeah, Shane can talk a little bit maybe about the modeling.
Yeah, like I work with our modeling. I do a lot of the capital work in that, so I work with the modeling group a lot. But that night, I was impressed with the information they were getting for us and how quick they were getting it. Like, I was impressed. We talked about different scenarios, running a 8-inch bypass, a 6-inch bypass, and they'd come back an hour later and say, that will only give you an extra hour. So it wasn't worth the work to do it. And I was just impressed with how they got that information for us. That's something I'd like to look into myself for my future. Yeah, the modeling department was a great help that night for us.
In a nutshell, anytime anything happens, especially if it's a 400 mil pipe or larger in the distribution system, you contact the modeling department and you tell them what work you need to do, and they'll let you know what the impact will be. In the immediate area right across, or it could be no impact. It's insignificant. So we rely on them quite a bit, and it's relatively sophisticated, assuming all the valves in the system are in the position that they believe they should be in. Periodically, we make mistakes, and let's say we have a main break and we close 5 valves. However, when we're turning the water back on, we only turn 4 back on. That one valve may impact or maybe make the prediction, the modeling not quite as accurate. So believe me, they're on us all the time to make sure that check all the valves and are they in the position that their home position, the position they should be in.
Right. So
Ignatius, I have a question. Yes. For some reason, yes, my hand raising doesn't work. I have no idea.
Okay, that's fine, Ton. You go ahead with your question.
But I'm very upset that I can't find the little thingy. But anyway, I have a question for Elaine. I mean, it's very interesting to hear about your experiences. A question about the wastewater effluent. Are you concerned about pharmaceuticals in the wastewater? Do you remove it from the treatment, during treatment?
Yeah, so we have a program right now on our contaminants of emerging concern.
Yeah.
We're running a conventional plant, so we don't have a lot of removal of certain things across the conventional plant. Once we get to the biosolids, we do thickening and then we do a lot of incineration. So we're seeing from the point of biosolids and the liquid train coming out of the ash, a lot of it gets destroyed. But what we're really, as I say, focusing on now is our contaminants of emerging concern. If anybody is going to WEFTEC next week, our consultant is actually doing a presentation on the program. But that's another one we can do a presentation on the program. We're working with University of Toronto on the water side, and on the wastewater side, we're doing some work with Sheridan College, and we're doing work with some other one, and we're just creating as well scalable plants, just so that we can run different treatment through them and see how the effect is.
Okay, so the effluent still has some.
Still has
Some-
some in it,
some-
not
some-
as much just because of
Yeah.
the incineration and the process we go through. As we start to do more, we're actually doing a round of sampling in next month. That as we get more results, it's something we can definitely share.
Now, I'm not sure if the participants understand the issue with pharmaceuticals. The major issue is that discharging pharmaceuticals in the wastewater, in the effluent, in the environment, increases the risk of antimicrobial resistance among the bacteria. And of
Yeah.
course, the hormones that are taken up by organisms and so can have significant environmental as well as public health impacts. Thank you very much.
And especially with like an ecosystem in the Caribbean,
Yeah.
with as some of the pharmaceuticals get through, what they're finding is some of the researchers is there's a definite increase in more a female population because of the release of things like the birth control pills,
Yeah.
the HRT hormone, a lot of that versus having males. So it upsets kind of the ecosystem. And then we're also looking at oh my gosh, I can't even think of the names. We've got a whole suite of stuff we're looking at, but yeah, definitely another presentation.
This is a serious issue. Yeah.
Yeah, hugely,
Right.
yeah.
Is it PFAP or
That
microplastic?
would be it. Our PFAS we're looking at as well, yes. And that's the challenge. We just with having the variety of industry, what is good, where we have the pharmaceutical makers here, most of them are on the west side of that. It goes to our smaller treatment plants. So we're doing some really great focus work at that wastewater plant versus our large one. Excuse me.
Bless you.
That's you.
Thank you.
Thank you.
Okay, Steph Dorville, do you want me to ask this question? I will refrain from asking this question for you. I think you might have to ask that yourself.
You know what, we have hired a number of people. We actually have one of our project managers. She's originally from Jamaica. We've actually got a couple of operators from Trinidad. There's one of our admin staff is from Jamaica. She just got her residency papers here. She's getting married and her husband's already asking about jobs. So keep in touch. Check out Peel Region all the time. We've got definitely a growing area. We've done a study. We need about 50 more operators over the next few years. So if you can handle the cold.
We need to keep our operators in the Caribbean.
I know. We'll do a job exchange. You guys can come spend a winter and then you'll just love being in the Caribbean.
I'm in.
We can twin. We can
There you go. Exactly.
There you go.
Okay, I think we have exhausted our time, and we'd like to thank you so much, Elaine, and your team. This is a very interactive and very conversational presentation. I think we covered a range of areas from some of the challenges that you face, and how you were able to maneuver through all of this. Your putting safety of your workers first, issues to do with cross-contamination, emergency situations, and the sort of response planning and mechanisms that you have for that. And as well as some of the great questions that came out from our audience. So you have so much more that you would like to speak about, including backflow and some of the other issues that you raised. So Valerie, we always have time for that. So
Yeah.
we can always,
You've
once she's
given me your list of
available,
dates now, so I will be. I'm
yeah, we
working
can try to
on that.
fit you in again some other time.
Yeah, and
So
if you guys have a problem that you want to talk through or say, hey, have you heard about this? We can definitely come back and even talk about that and work through people. We're here to help, and it's all about education and helping one another.
Thank you so much for that. We look forward to continuing our conversations on a Wednesday afternoon. If it's Wednesday, it's CAWASA Wednesday webinar. And let me say thanks to our sponsors, Operators Without Borders, and Valerie Jenkinson, the chair of Operators Without Borders. Thank you all for joining us. Until
Thank you.
Thank
we
you.
meet again,
Thank
we'll
you
keep
all.
in touch. Bye-bye.
Thank you.
Thank you, Ignatius.
Uh,
Thanks, Elaine.
Thank
Good night.
you.
Bye.